Okay, so this is section 8.2, and it starts off with reference angles. And what a reference angle is the smallest angle measured to the x-axis, kind of no matter where you are in the coordinate plane. It's always taken as a positive, and what its use is that we're pretty good at looking at things over here in the first quadrant. And so say this is 30 degrees, just for instance. There's going to be this kind of matching angle over here that's the same triangle, and it's 150 degrees all the way to it, but it's generally easier to think of it as another 30 degrees with a negative x. And so kind of once we learn what happens in the first quadrant, we can apply that. I can apply it down here. If this was, it'd be 180 plus 3210. Again, we could think of this as a 30 rather than going, okay, 210 degrees, what would that be? We're referencing it off the x-axis. So in this case, this angle would have the same x and y values as this one, except they'd both be negative. So that's the idea of a reference angle. So let me show that with a couple of examples. So the first one I did was number 2. And this one was 274 degrees. And we're looking for the reference angle on that. So if we subtract off 270, so this will go 90, actually let's do that. So this is 0, this is 90, this is 180, this is 270, and then either, back to 360, and it keeps going from there. And we always measure, right, counterclockwise. If an angle's negative, then we measure clockwise from the x-axis. So 274 would be just a bit past 270. It'd be 4 degrees past there. So not drawn to scale, but something like that. So the reference angle isn't this 4 degrees to the y. It is always, like I said, measured to the x-axis. So it is 90 minus 4, so that'd be 86 degrees would be the reference. So it's the same triangle as this one up here. The only difference is the y value would be negative rather than positive like up here. Next one I did was number 4. And so this is 138 degrees, or 138.6 degrees. So if we think over here is 180, and here's 90, it's somewhere right around here. So that would be 138 going this way. But again, the reference angle is relative to the x-axis. So it's going to be that angle right there. And if we go 180 minus this, we get 41.4 degrees is what would be left for the reference. Okay, so the next thing we have to do is kind of work out what all the signs are going to be for the various functions in the different quadrants. So first off, the quadrants are labeled, this is our first quadrant, second quadrant, third quadrant, and fourth quadrant. I don't know why they use Roman numerals, but they still do. And we do counterclockwise. Angles are measured, I'm sure you already know this, from the x-axis counterclockwise. And then if we have a negative angle, it's measured still from the x-axis, but clockwise that time. So for this, we have, in this first quadrant, x and y are both positives, and so that's going to mean everything, all these trig functions are going to be positive in the first quadrant. So we'll say all positive. In the second quadrant, x is negative and y is positive. And so anything involving y is going to be positive, anything involving x is going to be a negative. So our functions that don't have x are sine and cosine. So sine and cosecant. So those two are positive, everything else is negative in the second quadrant. In the third quadrant, we have double negative for x and y. And so if we have both x's and y's, it would come out positive. If we only have one of each, it'd be a negative. So the positive ones there are going to be tangent and cotangent. And finally, in the fourth quadrant, x is positive and y is negative. So things involving x are going to be positives, things involving y are going to be negative. So our only ones with x's, remember r is always positive because it's a distance. So our x's are cosecant and secant, or cosine and secant. So for instance, if we know, that cosine is positive on something, we know it's going to either be in the first or the fourth quadrant. If we know tangent is positive, we know it's either going to be in the first or third quadrant. Likewise, if we know sine is positive, we know it's going to be in either one or two. And so sometimes there's choices on that. So this is how we find, which angles it could possibly be. So let me do some examples using this. This picks up with number 6. Let me read the directions here. If theta is an angle in standard position, state what quadrant its terminal side can lie in if. So for number 6, we have theta is 123 degrees. And then we're just trying to figure out which quadrant that would be in. And so if we kind of look back at this is 0, 90, 180, and 360. And so 123 is going to land in the second quadrant because it's between 90 and 180. So this would say quadrant 2. Next one up is number 8. This is negative 47 degrees for theta. And so negative 47 degrees would be measured clockwise from the x-axis. And so it's about 45, so I'd put it around here. So that's going to be in the fourth quadrant. 10. Theta is 415 degrees. Okay, so that's bigger than 360. So all we have to do there is go 415 minus 360. And that's going to give us 55. So what that means is that for 415 degrees, we'd start here on x. It would go once around, and that would be 360 degrees. And then it's going to go another 55 degrees. So that puts it in the first quadrant. 12 theta is 845. And so for 845 degrees, if you can see that 360 times 2 is 720, that tells you how much to take off. If this was a really large angle, you could do 360 goes into 845. I think it comes out 2.3 ... And so that means it's going around twice and then another third or so of the way. So what I'd want to do is go 845. 2 times 360 would be 720. And take that off. So 5, 2, 1, 125 degrees. And so that's going to lie in quadrant 2. So the next one is give the algebraic sign of the sine, cosine, and tangent of the following. Do not use your calculator. So that's kind of getting more at these signs. So for 22, we have 110 degrees. And so sine, so this is in the second quadrant, right? Because it's between 90 and 180. So sine is our y function, and so it's going to be a positive. Cosine, so over in the second quadrant, x is negative, so cosine will be negative. And then a tangent has an x in it, so it's also going to be negative. So tangent's only positive when they're both positive or both negative in the first or third quadrants. Next one is 28, so this one's a little bit different. We start a clean piece of paper. So the next question is number 28. And this looks like actually let me read the directions. So find two positive angles less than 360 whose trigonometric function is given. Round your angles to the nearest tenth of a degree. So this is going to be tangent theta equals negative 0.1587. And so notice this time we're not given the angle, we're given the ratio. This is the y over x side. And so in general, if we think of it as, tangent x equals y, where x is an angle and y is the ratio, what we're given here is the y side, and we need to find x. So what we need to do is what's called either, for tangent, arctangent, or the inverse of function for tangent, which is basically tangent y equals x. And we have two different notations for that. We can write it as tangent with a little -1 and then the value right here, or we can write it as arctan. And so inverse or arc, these are the same thing. They're both where we're plugging in the ratio and we're getting out the angle. And you should see this as the second function on your sine, cosine, tangent buttons of your calculator. So for this one, and I'm used to using the little -1, so I'll use that, but arctan means the same thing. So this would be tangent, or inverse tangent, of negative 0.1587. So if you put that in the calculator, you should get to how many decimal places? 1/10 of a degree. So that should come out, where did it go? Negative 9.0 degrees. And so we're supposed to find two angles that could work for. So we'll make a little sketch here. So -9 degrees would be somewhere down there in the fourth quadrant. And then tangent is negative in the fourth and second quadrant. Just remember back here, tangent was positive in 1 and 3. So we have a negative value for tangent, so it has to be in 4 or 2. And so that means our second angle is going to be that one right there. So measuring to this one, it's going to be 9 degrees short of 180. So our first angle is going to be 171. And then our second angle is measured from, again, the x-axis all the way around, because we want these to be between 0 is less than, our theta is less than 360 degrees. So they gave it to us as -9, but we have to think of it as 9 less than 360. So this one would be, 351. So 171 to the first one, and then 351 degrees to the second one. So number 30, same directions, and this one is cosine theta equals 0.3215. So we do inverse cosine of this, and then that's going to come out to 71.2 degrees. So if we think about what that looks like, 71 would be somewhere around there. So cosine is positive, so we need the other quadrant where cosine is positive. And cosine is positive when x is positive, so that happens in the first and the fourth quadrants. So this other one that we're looking for is right down here. And so this is where I can either go 360 minus 71.2. That's probably the easiest way, because it's the 71.2 short of the axis. So I'm kind of using a reference angle there. And that would be 288.8 degrees. So if we measure all the way around, then we get 288.8. Number 33, just because I wanted to get one with sine in. So this one was sine of negative 0.6358. So I'm just kind of jumping to right here. And so equals our theta. So if we plug that in our calculator, we're going to get theta equals negative 39.5 degrees. And so with this, it's giving us the fourth quadrant version. And the reason is because of how they have to limit the, oh boy, you don't care about this. I'm going to skip over that because I think it's just going to be confusing. And they really don't emphasize it in the book. So let's just say this is what we got. And so negative 39.5 is going to be somewhere down here. And so sine is negative. Well, first, sine is positive in 1 and 2, so that means it's negative in 3 and 4. So the other angle we're looking for is right down here. So this first one would be 39.5 degrees against that reference angle past 180. So if we look this way, that's going to be 180 plus the 39.5. And so that's 219.5 degrees to here. And then the second angle is going to be all the way to there. So I would probably think of that one as 360 minus that reference. And that comes out to 320.5 degrees. Okay, and this last one, number 34, is the same thing, except it's cotangent, secant, and cosecant. So let me show one of those. So 34, we have cotangent of theta equals 2.8458. So we want to do, well, in this case, so we don't have a cotangent button, so we need to do tangent. So we're going to do tangent theta would equal 1 over this value, because remember it equals 1 over cotangent. Let me write that out. And cotangent, we just decided equal this, or it's given as that. So I'm just substituting this in for cotangent. And then if I clean that up, actually I didn't clean it up, I let the calculator clean it up. But so now we have tangent theta equals this value. So then that means the inverse, or arctangent of theta would equal, inverse of this, 2.8458 will give me my theta. And so if you put that in the calculator, we're going to get about 19.4 degrees. And so cotangent was positive, so that happens in quadrants 1 and 3. So 19.4, somewhere here. And then the matching one is going to be somewhere down there in the third quadrant where tangent is also positive. So this is our first angle right there, 19.4. And then our second one is going to be 180 plus that 19.4. So there's first answer, and then 180 plus 19.4, and that's going to be 4991. So 199.4 degrees for the second one.